Now let's study about trigonometric identities. Let's start with definition of identity. An identity is an equation that is true for all the values of the variables involved. Example, x plus x equals to x. This implies 2x equals to x. Here in these examples the equation is true for the values of a variable involved, so this is an identity. Let us now define trigonometric identity. Trigonometric identity. An equation involving the trigonometric ratios of an angle is called a trigonometric identity, where the equation is true for all the values of the angle involved. Let's now see some basic trigonometric identities in detail. Some of the basic trigonometric identities are given as follows. Cos square A plus sin square A equals 1. 1 plus tan square A equals secant square A. Cot square A plus 1 equals cosecant square A. Now let's see these trigonometric identities, and also establish new identities using them, in detail. Let us prove the trigonometric identity of cos square A plus sin square A equals 1. Consider a triangle ABC, right-angled AB. By applying Pythagoras theorem, we have AB whole square plus BC whole square equals AC whole square, make it as equation 1. Dividing each term of equation 1, that is, AB whole square plus BC whole square equals AC whole square, by AC square we get AB whole square by AC whole square, plus BC whole square by AC whole square, equals AC whole square by AC whole square. AB by AC whole square plus BC by AC whole square equals AC by AC whole square. On simplification we get AB by AC whole square plus BC by AC whole square equals 1 square, make it as equation 2. As we know that sin A equals opposite side by hypotenuse. By observing the right angle triangle ABC, BC by AC equals sin A. Similarly from the triangle ABC we get AB by AC equals cos A, since cos A equals adjacent side by hypotenuse. Substituting AB by AC equals cos A, and BC by AC equals sin A in equation 2, that is, AB by AC square plus BC by AC square equals 1 square. We get cos A square plus sin A square equals 1 square. Therefore cos square A plus sin square A equals 1. The above identity is true for all A, such that A lies between 0 degrees to 90 degrees. Hence this is said to be a trigonometric identity. Let's prove the trigonometric identity of 1 plus tan square A equals secant square A. Consider a triangle ABC, right-angled AB. By applying Pythagoras theorem, we have AB whole square plus BC whole square equals AC whole square, make it as equation 1. Dividing each term of equation 1, that is, AB whole square plus BC whole square equals AC whole square, by AB square. We get AB whole square by AD whole square, plus BC whole square by AD whole square, equals AC whole square by AD whole square. This implies that AB by AD whole square plus BC by AB whole square equals AC by AD whole square. On simplification we get 1 plus BC by AD whole square equals AC by AD whole square, make it as equation 2. As we know that tan A equals opposite side by adjacent side. By observing the right angle triangle ABC, we get BC by AB equals tan A. And similarly from the figure we get AC by AB equals secant A, since secant A equals hypotenuse by adjacent side. Substituting BC by AB equals tan A, and AC by AB equals secant A in equation 2, that is, 1 plus BC by AD whole square equals AC by AD whole square, we get 1 square plus tan A square equals secant A square. Or 1 plus tan square A equals secant square A. The above identity is true for all A, such that A lies between 0 degrees to 90 degrees. Hence this is said to be a trigonometric identity. Note, as tan A and secant A are not defined for A equals 90 degrees. I is taken as less than 90 degrees.